Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to calculate the percentages of two substances in a mixture given the total amount of the mixture and the total amount of product that's formed by a reaction using the mixture. So let's get into this. So in this particular problem, we have a mixture contains calcium carbonate and magnesium carbonate. A sample of this mixture is weighing 7.85 grams was reacted with an excess amount of hydrochloric acid. If the sample reacted completely and produced 1.94 liters of carbon dioxide at 25 degrees Celsius and 785 millimeters mercury, what are the percentages of calcium carbonate and magnesium carbonate in the sample? So, the first thing we need to begin with is there's going to be a system of equations. We're going to have two unknowns and we're going to need two equations. The first place we need to start with is a balanced equation. We need the balanced equation for the two reactions. So let me go over that. So here we have calcium carbonate and magnesium carbonate, and they're both reacting with HCl. So I'll write the calcium carbonate first. So we have CaCO3 solid plus HCl aqueous. And we need to think about the products. Now, right away, you want to think about what kind of reaction are we dealing with here? So we have HCl that can ionize into ions, even though it's a molecular substance, so it's aqueous. So it can ionize into ions. And here we have an ionic substance, which is going to dissociate into ions, right? So we have two compounds, both are ionic, and that's usually a dead giveaway that you have a double displacement reaction. And as you know, with any double displacement reaction, you can predict the products by putting the outside ions together and then the inside ions together. So here we're going to put the outside ions together. So Ca with Cl, so that's going to give us CaCl2 because calcium has a 2 plus charge, chloride has a -1 charge. And then the H and the COH are going together. I'm sorry, the CO3 is going to go together. And so this will be aqueous plus this will be H2CO3 aqueous. Now, so the CO3 has a 2 minus charge, so we're going to need 2 positive hydrogens to balance the charge. So if you stop here, you're probably wondering, well, where did the carbon dioxide, where is that? You have to recognize, this is one of those things where you got to recognize that if you produce a carbonate, right, if you start with a carbonate, I should say, and you're reacting with an acid, you're going to get carbonic acid. If you get carbonic acid, you need to know that carbonic acid is going to right away decompose into water and carbon dioxide. So this is going to become water and CO2. So those two products come from the carbonic acid. So we need to replace the carbonic acid with water and CO2. So H2O liquid plus CO2 gas. Same thing with the magnesium carbonate. So we'll do magnesium carbonate. So MgCO3 solid plus HCl aqueous. And that's going to give me MgCl2 aqueous plus H2O liquid plus CO2 gas. Okay, now that we have the equations, we can balance them. So let's make sure they're balanced. We have one calcium. I have one carbon. I have one hydrogen or one chlorine, two chlorines. So I'm going to need two on this side. So the chlorines are balanced. I have two hydrogens here, and I have two hydrogens there. And finally, I have my oxygens. I have 3 oxygens here. I have 1 here and 2 there. That's 3. So that's balanced. Let's do the same thing with magnesium. It's probably going to have the same thing because the magnesium here has the same charge as the calcium, so everything else is going to be the same. But let's just double check. So I have 1 magnesium here, 1 magnesium there. I have 1 carbon, 1 carbon. I have, well, I already balanced it, but let's double check. So I have 1 chlorine here, I have 2 chlorines there, but I do have to put the 2. So there it goes again. And then I have 2 hydrogen, and again I have 3 oxygen, and I have 1 and 2, that's 3. So now I have both equations balanced. So that's step number 1. Okay, now we need to figure out how to go from your amount of the substance that we're dealing with, this mixture, to the amount of product form, which is the carbon dioxide. So they gave us in our sample the total amount of the mixture is 7.85. So the amount of calcium carbonate and the amount of magnesium carbonate together is a total of 7.85 grams. So I can write that as an equation. But first, I want to identify. So we're going to call MgCO3, the amount of MgCO3 in our mixture, we're going to say that's X. So X grams of magnesium hydroxide, or magnesium carbonate, sorry. Actually, let's be consistent. I'll do Ca. Calcium carbonate is X, and magnesium carbonate is Y. So X is going to represent the grams of calcium carbonate in the original mixture, and Y is going to represent the grams of magnesium carbonate in the mixture. So if that's the case, then X plus Y is going to be equal to the total, which is 7.85 grams. Okay, so here's the first equation. So I have the two substances added together equals the whole. Okay, so the next thing I'm going to do is I got to convert each of these gram amounts to moles. Okay, so that's the next step. I have to convert this to moles because notice they gave me temperature and pressure, and we're dealing with a gas, carbon dioxide, so we're going to have to use a gas law, ideal gas law. So in order to use ideal gas law, I need moles. So we're going to convert each of the amounts of the mixture, we're going to convert that to moles of the carbon dioxide gas that's produced from each of these. Okay? And so we're going to do that by just doing our normal stoichiometry conversion factor conversion problem, right? So let me show you what I mean. So all I'm going to do is I'm going to take X, and I have an X grams, right? We'll say grams. X grams of the calcium carbonate, right? So I'm just writing grams of calcium carbonate to be clear that that's what X is referring to. So I have X, that's grams of calcium carbonate, over 1. And then I'm going to just use stoichiometry to convert to moles of the carbon dioxide. And so the first thing when you're doing stoichiometry, remember, there's three parts to the stoichiometry problem. First part is to convert whatever unit you're given to moles. So convert to moles first. Second, convert moles to moles using the mole ratio, moles of A to moles of B using the mole ratio in your balanced equation. And then the third part, convert moles to whatever unit they want. If they only want moles, which is in this case we just want moles, then we don't need to do that step. So I'm going to use my molar mass. So I got to calculate the molar mass of calcium carbonate, and when I do that, it's 100, 0, 80, 872. So 100.0, what did I say it was? 872 grams of the calcium carbonate. And then I have 1 mole of the calcium carbonate on top. So grams are going to cancel out. Now that I have moles of calcium carbonate, now I can use the mole ratio in my balanced equation. So you can see here that 1 mole of calcium carbonate is going to give me 1 mole of the carbon dioxide. So it's 1 to 1. So 1 mole calcium carbonate on the bottom and 1 mole of the carbon dioxide on top. So moles of calcium carbonate cancel out. And now I have moles. So now all I need to do is multiply across top, divide by the bottom, I get my answer. And when I get that, I'm going to get an answer that's in terms of x. Don't forget I have an x here. So x is going to be multiplied by 1 divided by this. And so they're all ones. So it ends up just being x divided by this. So then the amount of carbon dioxide produced is going to be x over 100.0872. And that's going to be moles CO2. Oops, should write that better. Moles of CO2. So from an x grams of calcium carbonate, I got x over 100.0872 moles of carbon dioxide. So I now have the number of moles of carbon dioxide in terms of x from the calcium carbonate that was in my mixture. Now I can do the same thing for my magnesium carbonate. So this time I'm going to start with y amount of the calcium. Did I say calcium carbonate? I meant magnesium carbonate. So here, again, I'll just do it down here. So I have a y amount, grams of I keep saying calcium, magnesium carbonate over 1. And again, I want to convert grams to moles so I can use my mole ratio in the balanced equation. So I got to calculate the molar mass, and that's going to be 84.3142. So that's 84.3142. Let me double check that. Yes. Okay, so that's going to be grams of the magnesium carbonate. And then on top is 1 mole of magnesium carbonate. So grams cancels out. Now I have moles of magnesium carbonate. And so now I'm going to use the mole ratio. Again, it's 1 mole of magnesium carbonate gives me 1 mole of the carbon dioxide. So it's a 1 to 1. So 1 mole of magnesium carbonate on the bottom and 1 mole of carbon dioxide on top. So moles of the magnesium carbonate cancel out. Now I have moles of carbon dioxide. So again, all I'm going to do is multiply y by 1, divide by this, divide by 1. So basically it's just going to be y over the molar mass. So that's equal to y divided by 84.3142 moles of CO2. So now I have the amount of carbon dioxide from X amount of calcium carbonate in my mixture, in terms of X, and I have the amount of carbon dioxide from a Y amount of magnesium carbonate in terms of Y, right? So, and then both of these added together will give me the total amount of carbon dioxide, and they told us that that is going to be 1.94 liters of volume. So now we can go ahead and put this into our equation, but what we need to do is yeah, let's go ahead and do this. Yeah, so eventually what we need to do is we're going to need to do a substitution because we have two equations here. So let me write the equation down so that we get the total. So we got the total moles. We got to add these together here. So we'll go ahead and add those together. Let me erase this and give myself some space. So basically our second equation is going to be, so X over 100.0872 plus Y over 84.3142 is equal to the total number of moles of carbon dioxide. So I'm going to erase this so that I don't need that anymore. So I have the total moles of carbon dioxide written in this equation here in terms of X and Y. And I'm going to have to use PV equals nRT. And here they're giving me the volume, the total volume of the carbon dioxide. So I'm going to have to use here the total number of moles, right? So here it's going to be total times RT. So what I need to do is, again, we want to find the total amount, we want to find the percentages of calcium carbonate. So I'm going to need to take this, solve for one of these, X or Y, it doesn't matter, and substitute it in for X or Y here. So that way when I plug it in here, I'll have one equation and one unknown. So let's go ahead and plug this. We'll go ahead and plug this into here. And so it's going to look ugly. So just bear with me. So it's going to be the pressure times, well, what is the pressure? Let's put in the pressure. The pressure here, we need to convert this to atmospheres because our R value is going to be in atmospheres. So let's go ahead and do that. So we have 785 millimeters of mercury. And we know that 1 atmosphere is equal to 760 millimeters mercury. So we'll use that as a conversion factor. So 760 millimeters of mercury on the bottom and 1 atmosphere on top. So millimeters of mercury are going to cancel out and I get atmospheres. And when I calculate that out, I get 1.0329. 1.0329 atmospheres. And so since I have 3 sig figs here, I should have only 3 sig figs here. So I'm going to underline that. Keep at least 1 digit to avoid rounding errors. Okay. And so that I have in atmospheres now. And then we need to make sure that the temperature is in Kelvin. So we're going to add 273.15 to 25. So 25 degrees Celsius plus 273.15 equals and that's going to be 298.15 Kelvin. And again, the reason we want to convert to Kelvin is because our R constant here has the units Kelvin in it. So we want to cancel that out with Kelvin here. So we've got atmospheres, we got Kelvin, and we want liters, and we have liters for our volume. So we're good with everything. So now we can go ahead and plug everything into our equation here. So again, I'm going to erase this. Let me write this up here. So 298.15 Kelvin and 1.0329 atmospheres. Okay. So now I'm going to plug everything in. So we have pressure. Pressure is this in atmospheres. So I'm going to have 1.0329 atmospheres. And then I'm going to multiply that by volume. So the volume here is 1.94 liters. 1.94 liters. That's going to be equal to the total amount of moles, which is this right here. So now I'm going to have X over 100.0872 plus Y 84.3142. So that's my total number of moles. And that's going to be multiplied by R, which is 0.8206. And that's again liter atmospheres over Kelvin mole. And finally multiplied by the temperature, which is 298.15 Kelvin. Okay, so here's my equation. Here's the PV equals nRT. And then notice here I got X and Y, but I only have one equation here. So I'm going to now have to use this so that I can solve for one of these and substitute in. So I'll go ahead and solve for Y. So if I subtract X from both sides, then I'll get Y, and then I can substitute. So let's go ahead and do that. So this is going to be, I don't need that anymore. So this is going to be Y is equal to 7.85 grams minus X. So now that I have this, Y equal to this, I can now substitute this in for Y. And so then I get, let's see here, I'm going to get 1.0329 atmospheres multiplied by 1.94 liters is equal to, and this is going to be, again, X over 100.0872 plus, and this time instead of Y, it's going to be this minus X. So then this is going to be 7.85 minus X over 84.3142 multiplied by my K value here. And by the way, I should have moles in here. So moles and moles. And so here I have, again, 0.08206 liter atmospheres over Kelvin mole multiplied by 298.15 Kelvin. Okay, so now that I have one equation, I have everything in terms of x. Now here it's just algebra. So let's do the algebra. So I'm going to go ahead and erase these equations. We don't need these anymore. We don't need, well, I'll keep the calcium CO3, the calcium carbonate equal to X over here, magnesium carbonate equal to Y. So we remember those because we've got to remember what we're solving for. And so I'll keep the X plus Y is equal to 7.85. That's going to be useful later. And so now what I'm going to do here, let me get rid of all of this stuff so there's no confusion about what we're looking at. Okay, so now what I'm going to do is I basically just going to multiply and simplify this a little bit. So these two numbers, this can be multiplied through here and divided by these. And then these two can be multiplied together as well. And then over here, we can begin to cancel out our units here. So I have moles here, moles here. These moles are going to cancel out with moles here. And then Kelvin is going to cancel out with Kelvin here. And then we have liter atmospheres on this side. So I'm going to go ahead and multiply these two together. And then when I multiply those two together, I get 2.0038. So 2.0038. And that's going to be liter atmospheres because the atmospheres and liters are multiplied together as well. So I have liter atmospheres here. And remember, so because this has 3 sig figs, I underlined it here. And then this has 3 sig figs. So therefore, when you multiply and divide, remember that your answer should have the same number of sig figs as what you multiplied and divided. So I should put this up here because this is going to give me more room. So 2.0038 liter atmospheres. And because the least number of sig figs is 3, I'm going to underline this 0 here, 1, 2, 3, and then I'll keep the 3.8 because I still have calculations to do and I don't want a rounding error. So that's this part here. Now I want to do this part. So I'm going to multiply this times this, and then I will multiply that through the top here and divide by the bottom. Maybe I'll just do that in steps. So let me multiply this here first, and then I'll do that step by step. So when I multiply these two together, I get 24,466. So then this becomes 24.446 liter atmospheres. So then this becomes equal to this. So I'm going to rewrite this. So X moles. Well, the moles are canceled out, so it's just X. So X over 100.0872 plus, and then it's going to be 7.85 minus X over 84.3142. And multiplied by 24.446, and then that's liter atmospheres. Okay, so I can go ahead and erase this. And now the next step is to take this and multiply it through and then divide by what's on here. So here, this can be separated here in a moment. So I'll just multiply this. And when I multiply this through, so this is going to be, I'll move this over here. So this is going to be 2.0038 liter atmospheres equal to, and then multiply this through. So I'm going to multiply that. So this is going to be 24.446 liter atmospheres divided by 100.0872 plus, and then I'm going to multiply this by both of these on top. And when I multiply this by this, I get 192. So 192.0595, I believe. 192.0595, yes. And so that's going to be, and I'm going to separate these two with the common denominator. So that's going to be divided by 84.3142. And then minus x, and then I'm going to multiply this by the x. So it's going to be minus 24.446 times x. Oh, I forgot my x over here. So this is supposed to be times x. I forgot x on this side. So it's be x and then liter atmospheres. And then this is by itself, and then this is x liter atmospheres. Okay, and then it's divided by the 84.3142. Okay. Now, the thing I should mention here, now that we have liter atmospheres, actually we don't need the parentheses anymore since we multiplied this throughout. Notice the liter atmospheres here and the liter atmospheres here. And so that's going to cancel out, right? So we're gonna end up canceling that out anyways. So this is gonna end up canceling out, but we'll see that in a moment. Okay, so now that we have this kind of simplified a little bit more, we can simplify it by dividing the numbers now to get rid of the fractions. We don't want fractions, so we're gonna divide those numbers, and then when we do that, we're gonna get the values that we need. And so let's go ahead and do this. Oh, by the way, oops, I forgot. So this should also have liter atmospheres. Okay, so now we're going to divide these two. When we divide these two, again, we'll write this 2.0038 liter atmospheres equal, okay, we're going to divide these. When we divide those numbers, we get 0.2442. So this is going to be 0.2442x. And that's going to be liter atmospheres. And then dividing these two, we get 2.2779. So 2.2779 liter atmospheres. And when we divide these two, we're going to get 0.28993. So 0.28993. And again, that's x liter atmospheres. Okay, so it's pretty simplified here. So next, what we're going to do is we're going to add our like terms together. So we have an x term here, and we have an x term here. we're going to add these two together. And when we do that, we're going to get negative 0. So again, this is going to be 2.0038 liter atmospheres. And that's going to be equal to, when we add these two x terms together, it's going to be equal to a negative 0.02. What was the number? Sorry, 4573. 4573 x, again, liter atmospheres. And that's going to have, we have this left over, so 2.2779 liter atmospheres. Okay, now the next terms, this term here doesn't have an x, and this doesn't have an x, so we're going to have to bring this over on this side here so that we can have x by itself. So then we're going to subtract 2.2779 liter atmospheres. Subtract over here, minus 2.2779 liter atmospheres. And so when we subtract these two, we get negative 0. So it's going to be a negative 0.2749 liter atmospheres. And that's going to be equal to this right here. So negative 0.04573x liter atmospheres. And now you can see that the liter atmospheres are going to cancel out because when we divide by this number, the liter atmospheres are going to divide as well. So that's going to cancel out with this. So we want to now get x by itself, and so we just divide both sides by negative 0.04573. So we're going to divide here. So negative 0.04573. And then on this side, we're going to have negative 0.04573. This is going to cancel out, leaving us with x. So then x is going to end up equaling whatever this is, and then we calculate that, we get 6.011. 6.011. And what does this x mean? Let's go back to x. X here is our calcium carbonate, but not just calcium carbonate, but the grams of calcium carbonate. So what we have just found is the grams of calcium carbonate in our original mixture of 7.85 grams. So to find the grams of the other one, we just subtract, or in other words, we would plug back into this equation here. So remember, y is equal to 7.85 minus x. We just found x. So if we subtract, y is equal to 7.85 minus x, which is 6.011 grams, right? This is the total grams. And so when we subtract that, we get, what do we get? 1.8386, 1.8386 grams. And again, that's y. So then y becomes 1.83, is that 86? Yeah, 86 grams of the magnesium carbonate. Okay, so now that we have the gram amount of the magnesium and calcium carbonate in our mixture, they want us to find the percentages. So how do you find a percentage? It's very simple. It's the part divided by the whole multiplied by 100. That's going to give you the percent. So what's our part? The part is our x or y. Remember, x plus y gives us the whole. So in order to find the percent by mass, we're going to take the mass of a part. So we could take the mass of x or y, it doesn't matter which one we start with, but we can take the x of a part, the mass of a part y, or x, and divide that by the whole, which is 7.85 grams, multiplied by 100. So in this case, we'll take x. So x is going to be, or we'll say 6.011 grams of the CaCO3. Divide that by the grams of the total, which is 7.85 grams. And then we multiply that by 100. And when we do that, we get 76.3. So that's going to be 76.3% for the calcium carbonate. And then you could do the same thing. You could just take y, the y amount divided by the total, multiplied by 100 gives you the other percent. Or you can just subtract this from 100, and that'll give you the percent of the magnesium carbonate, because the two together gives you the whole, right? So if you know the percentage of the one, then you know the percentage of the other. So if you subtract this from 100, you should get 23.7. So the percent, this is the percent of calcium carbonate, and then 23.7% is going to be the magnesium carbonate. And so that, ladies and gentlemen, is how you do this problem. I hope you enjoyed this video. If you did, if you learned anything from this video, if this helped you in any way, then please like the video, share the video, hit that notification bell. Also, before you do that, hit the like button somewhere around here. And please do me a favor, subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. And, if you have a question or problem you need help with, put that down below. If you have a topic you would like me to cover, put that down below. I would like to do that for you. Thanks for joining me, and have a great day.